Hey guys, it's Mr. Kreisler. So today we're going to be talking about GCF, or finding the greatest common factor. For this lesson, you either have to really know your multiplication table and be really good with figuring out what numbers to divide and whatnot. Otherwise, prime numbers are going to be your best friend. Prime numbers will never steer you wrong. Just remember, our basic ones are 2, 3, 5, 7, 11, and 13. There are plenty more bigger prime numbers, but these are the ones you got to know. So for the greatest common factor, we're basically looking for the biggest number and or variable that we can divide the whole expression by evenly without getting a decimal. So for our first example, you have 9x plus 36. So if you do not know your multiplication table well, you would not recognize that 9 is a GCF right away. So in order to do that, we would have to do our tree. So 9 becomes 3 and 3. Our 36 becomes 2, becomes 18, becomes 2, which becomes 9, 3, and 3. So just like from my other lesson, if you take those two numbers, say 9 has 3 and 3 times 3, and the primes of 36 are 2 times 2 times 3 times 3. Got to see what matches up. Well, 9 has a 3, and 36 also has a 3. 9 has a second 3, and 36 also has a second 3. So our GCF here is 3 times 3, which is 9. So you might be wondering, okay, great, Mr. Kreisler, I got the GCF. What do I do now? Well, you take the GCF and you kind of pull it to the side over here. You go, well, I have my GCF, what's left? So when you take out a GCF, you're dividing by the GCF. So I'm saying 9 divided by 9 is 1, so 1x. 36 divided by 9, well, that's 4, and it's positive, so it's positive 4. And that's really it for finding the GCF. So we're going to rewrite this answer as 9x plus 4, because 1x isn't a proper way of writing it. Not incorrect, just not proper. And that's how you factor out using a GCF for that. Another example. This time we have variables, but let's ignore the variables just temporarily and look at the numbers. So I have 16 and I have a 4. So 16, let's break it down in prime, in case you haven't already noticed what the GCF would be. 2, this becomes 8, 2, this becomes 4. If you notice, oh, we must have a GCF of 4 in common. Say divide by 2, and 2. And now let's break down the 4, so 2 and 2. So if I were to write this 4 out, 4 is made up of 2 times 2. 16 is made up of 2 times 2 times 2 times 2. Well, we're dealing with all 2's, but how many 2's do they have in common? Well, oops, wrong color. They have a 2 and a 2 in common. So our GCF is 2 times 2, which is 4. So we divide by that GCF. So 16 divided by 4, 4 divided by 4. Let's pull out this 4. What's left? Well, 16 divided by 4 is 4. We have a plus, and 4 divided by 4 is 1. And then going, that's great, Mr. Kreisler, but what about those variables? Am I adding them? Am I leaving them alone? What's going on there? Variables are actually pretty easy. If every term has a variable, then the variable is part of the GCF. So since both of these have a p, p must be part of the GCF. Now look at the exponents. Which one has a smaller exponent? P to the third or p to the fourth? Well, 3 is smaller than 4, so the GCF is going to be p to the 3. And we're going to be dividing by the GCF just like before. And in case you forgot, you're like removing that amount from it. So 4 minus 3 is 1, so we got p to the 1. And p to the third divided by p to the third just kind of cancels out, so this just stays as 1. So our final answer is 4 p to the third. 4p, we don't need to write to the first, that's improper, plus 1. And that's what happens when we remove the GCF. That's it. Now, because you're looking at this, be like, oh, Mr. Kreisler, the whole prime tree, that's taking way too long. You're right. Here's a little trick. What is the smallest number here? 4 or 16? You're gonna look at me and be like, well, duh, Mr. Kreisler, it's a 4. Take that smallest number and divide it by the all other numbers. If it all works, that's automatically your GCF. So I know I can divide 16 by 4, so 4 has to be the GCF here. 4 divided by 4, once again, is 1. 16 divided by 4 is 4. So let's go back. The first problem, what's the smallest number here? 9. Can I divide 36 by 9? Yup. Can I divide 9 by 9? Well, you can always divide a number by itself, so automatically that is correct. All right, new example. I'll start with that trick I did before because it doesn't actually work in this example. What is the smallest number, 63 or 45? Well, 45 is the smallest, but can you divide 63 by 45 without getting a decimal? God, no. So that's not correct, and that's why I showed you the prime tree. So we have 63, and we have 45. Let's break both of these down using the prime factor tree. So 63 divided by 2 won't work. So let's try 63 divided by 3. That gives you 21. 21, I can still divide by 3, and that gives me 7. Since it's prime, I stop right there. Now 45. Could I divide 45 by 2? No. Could I divide 45 by 3? Yes. So we get 15. 15 we can also divide by 3, and we get up to 5. 5 is prime. We're done. Let's write out our numbers we're trying to find the GCF for with their prime numbers. So 45 is 3 times 3 times 5, and 63 is 3 times 3 times 7. Hopefully you notice it right away. They have a pair of 3's and a pair of 3 in common. So our GCF is 3 times 3, which means our GCF is a 9 again. So 63 divided by 9, 45 divided by 9. 9 is the GCF, so let's pull that bad boy out. 63 divided by 9 ends up giving us a 7. We got plus. 45 divided by 9 gives us a 5. And once again, we got to look at the variables. Do they both have an x? Yes. So GCF is part of x. Now, let's look at the exponents. Which has a smaller exponent? 2 or 6? 2 is smaller. X squared divided by x squared, well, they're the same thing, so they're going to cancel out. X to the 6th over x squared. So we're removing 2 of the x's from x to the 6th, which means we have x to the 4 left. So our answer is just 9x squared, parentheses 7, plus 5x to the 4th. And that's it. That's our answer. Hope you guys are getting this. We have one last one I want to show you. So I'm going to change this one up. It's just a smidge. Let's say that, yeah. All right. All of our terms, let's look at them. What is the smallest number? The smallest number here is a 3. Can I divide 6 by 3? Yes. Divide 9 by 3? Yes. If your answer is yes, then you don't have to do the prime factor tree. You already found it. So we know they all, oops, where'd it go? They all have a 3 in common. So we're going to divide all the numbers by 3. Pull out that GCF, which is a 3. 3 divided by 3 is a 1. 6 divided by 3 is a 2. 9 divided by 3 is a 3. Let's look at our variables. There's an x here, an x here, and an x here. So because they all have an x has to be part of the GCF. Now, what's going to be the exponent on that x? I have a 2, I have a 3, and I don't see an exponent. Well, if I don't see an exponent, I know there's an invisible 1 there. So x to the first divided by x to the first goes away. X squared divided by x to the first, well, 2 minus 1, so that's x to the first. And x to the third minus 1, well, 3 minus 1 is 2, so x squared. Now, I still have this variable y squared here, and I have a y here. But I don't seem to have a y in the last place. If you don't have a y in all of the terms, or you don't have the same variable in all the terms, it's not a GCF. So no GCF for y. So we're going to bring down the y just as is. Y doesn't change here. The y doesn't change there. So I wanted to rewrite my final answer properly. I have 3x, parentheses, y squared, plus 2xy, plus 3x squared. And that's it. I factored out my GCF, my greatest common factor. So remember our rules. First, check for the smallest number, see if you can divide all 3 of them by that number. If you can't, you got to do the prime factor tree. Next, look at all 3 variables, look at all 3 terms, and see if they all have the same variable. If they all have the same variable, then it's part of the GCF. To figure out what the exponent is, look at the smallest exponent. I have a 1 here, a 2 here, and a 3 here. So 1 is smallest, so it belongs there. And in the chance that they don't all have the same variable or the same letter, like in this example, you can't do anything, so the y just stays as is. So remember those rules and you'll be good. All right, hope that was a lot easier for you guys, and have a great day and ask any questions that you feel that you might need.